Yeah. Good morning, everybody. Back here with an IoT class. In the last class, we are discussing on the networking. What is the importance of a networking in an IoT project and M2M project? In that, we have discussed what is the need of a network, and then we have seen what is the WAN networks, when we are going to use this WAN networks, wide area networks according to the geographical regions that we have seen. And then we have gone with a local area network, that's a capillary networks we have started in the last class. So I'll share now the PPT and we'll move with that concept. Yeah. Now, capillary networks, as we have discussed, is that how our networks will be there and all our projects are. Now, what we are doing will be in a capillary networks, and just we are using a 2G or 3G or a 4G connection to connect to the internet and to other end of an backend process. So this is a simple networks which will be there. And the cost wise, it will be very less. Yesterday, we have discussed how an capillary networks will be there, battery operated, why due to cost reasons and all. In the last class, we had discussed that also. And then the communication, why we have gone with wireless and Zigbee also, that also we had discussed. Coming to the next one, that is the deployment considerations we have started, and in the deployment considerations, how a deployment can be done. So always the deployment of a device or network, means a capillary network, will be done based on a solution or a technological solution or an application, how based on application and all, it will be done, and always it will be motivated within a business logic. So that we have taken into the consideration. Now, that is the one particular thing which we have taken. In this particular class, we will continue in this particular deployment considerations. Scaling up for industrial applications and moving from laboratories into the real world creates a significant challenges. Yesterday, we have discussed how what is the difference between in laboratory and in industries scaling applications. If we do, for example, in institutions and all, what will be the real fact in that which we should see in outside, for example, drip irrigation system. Even Murugesh has explained very well about how the different things will work. Even they have told in agricultural systems, these are the terms and technologies which will work. Moisture level sensor and the temperature sensor will be there. Based on that, all these things will work. One plant or one or two plants they can take and they can work on that, and they can show a prototype. But when it comes to the real-time example in fields, in farms, then it will be a challenge when you come to the real world, how this low rate things or low power communication technologies will work. Either we'll have a connection with this particular thing, means how a connectivity can be established in a real world. This is a major problem which will be there. They can relate to the environmental factors, maybe, which impact upon a radio performance, or technical factors such as performance trade-offs based on the characteristics of medium access control and routing protocols, and physical limitations of devices, and practical factors such as maintenance opportunities. This is a major one in a real-time environment. What are the environmental factors which will affect that particular network? For example, assume that we are having a hotspot somewhere in 3 acres of land will be there, and we are having a somewhere the hotspot will be there. Assume that in that particular area or stage, you can't communicate, means the signal will be very weak. So what to do for that? Maybe radio frequency will be, performance will be very less, and technical factors. For example, we can't afford more than a hotspot device. For 3 acres or 4 acres of a land, if you are implementing your project and you are seeing within a small hotspot, the technical factors, it will be not related. So you have to use an access point with in a gigabyte capacity and a high performance capacity. It should work in gigabits. That type of an access points you may need, which in MBs and all, it won't works, or KBs and all, which won't works. So technical factors is also there. Okay, you'll think like that, we'll have some gigabytes access points here instead of an hotspot. Then gigabyte access point itself, just that device itself is of 1 lakh or 2 lakhs. So 1 lakh or 2 lakhs, if that device itself means farmer cannot offer that. So what we have to do for that? These are some technical factors such as performance trade-offs will be there based on technological and medium access control means how to access that particular control, and some physical limitations, maintenance problems will also be there. For example, somewhere in a soil you have kept the moisture level sensor, and what is the life of that sensor you are expecting that if assume that if some animals or somebody while walking or while plowing, something will happen and that voice will cut off, then the sensor will never work. A small voice will be there. So how you are going to maintain that particular entire equipments in acres of land? So these are the major problems which will arise when you think of the implementing a capillary, using a capillary networks, implementing a practical applications. And the next thing is the numerous deployment environments, that is factories, buildings, roads, vehicles are expected in addition to widely varying application scenarios and operational and functional requirements of the system. So it depends on where you are doing this particular thing. For example, in a home automation, I will use a capillary network and I will work. Yeah, it's a very good. You can use for home automation. Not at all a problem. The home automation, how you are using, I will keep some the box. I will keep and I will connect my device to the power there directly. A plug with the adapter, and automatically in a switchboard through the relay, I will give a connection. My lights will work and fans will work. It's not a big issue there. Why? Because Wi-Fi will be there in my house anytime. So that Wi-Fi password and all I have given to my device there, and it's working. Here, capillary network is very good. Means you doesn't need any practical problems here. Home automations you can do very easily, and like this type of things, home security things, factory related security things, and surveillance of cameras. What you are doing. That what I mean to tell you is where the power is available and some services is available in a building like that, and all implementation of this type of projects will be an easy one. When it comes to the environmental implementation of a factors, air pollution monitoring system and agricultural projects, and then any fire extinguishers in a forest. So, sorry, that type of projects, how you are going to implement practically. So that is a one important things you should differentiate and you should know about the things. And for example, now you can see the cradle system is there, and the solar panel. So how a big motors is needed to rotate that particular thing. Then, how to manage that particular thing. Yesterday, while doing a research on any that type of projects is there, the smart cradle system. When I'm working on that particular thing, I got a lot of projects or papers, n number of members they have did on that, especially in NIR, NITK, I think. There also NIT, there one student in a biomedical branch, he has submitted this as a project. And somewhat he has implemented in some practical sense. It comes to NIT and IITs. No? So I have sent that report even to Ashwini and Sinchana. Sinchana, did you got that? Sinchana?
Yes, yes,
Ashwini?
sir.
Did you got the mail?
Yes, sir.
Yeah, yeah. So you read out ma, that I try to implement in that way. Okay.
Yes, sir.
Just a try. That's it. Okay, in that particular manner, when we see that type of a things and all, so practical implementation with some big motors and all working, so that plays the things. Then key technologies. This section details a number of the standards and technologies currently used and under development that enable ad hoc connectivity between the devices that will form the basis of the IoT. What do you mean by ad hoc connectivity? That means device to device connectivity without any interference nodes which we are using or any infrastructure which we are using. That's an ad hoc. What do you mean by ad hoc? It should work with a wireless and one board will be there. Assume Raspberry Pi board. One Raspberry Pi board should communicate with another Raspberry Pi board, and that Raspberry Pi board should communicate with another Raspberry Pi board, like that. Or one Arduino board should communicate with another Arduino board, or a Node MCU. One Node MCU should communicate with another Arduino board in between. Why? Because to elaborate your project in a field, for that things and all, like connectivity between where internet is not needed here, you have to keep in mind. In ad hoc connectivity, where you are connecting a device to device through Wi-Fi, in this particular range, around some 20 or 50 meters, more than that 50 meters, 100 meters also. So you may not need any internet. So one node I will keep and another node I will keep. I will make node to node connectivity. At the end of the field, at one particular stage only, where hotspot is available easily, at that particular stage, the main node will be there and it will keep on communicating. So this is one of the best idea where for a practical implementation and all. So that part also we have to see when we are doing a project. And coming to the next, the technological term, that is the power line communication, PLC, prefers to communicating over a power or a phone, coax, etc. links. So how you are going to communicating over a which type of a lines you are communicating. This amounts to pulsing with the various degrees of power and a frequency, the electrical lines used for power distribution. This is very much important. How you are doing a power distribution in entire that field. What the power unit you are going to use. For example, assume I am using some 50 to 60 sensors for the 1 acre or 2 acres of a land, and so I am using some 10 to 20 boards. And all these boards and that sensors, whatever is there, and actuators, whatever is there, means solenoidal valves, whatever will be there, it may needs a power. So how you are distributing a power from one point? So this is another one challenge. How you are maintaining a power line communication? See, maintaining a power line communication is another one very important. If you see in a YouTube any projects like, for example, automation of a restroom, you see one of the best project which I saw in YouTube. If you see that type of projects, and then another way of a projects is there in any means even agricultural projects also you can see in that. The supply of a power to the fields means I think in 3 acres of a land, every point there will be not a power lines will not be there. Only at one the farmhouse, whatever will be there in one point of the 3 acres of land, the power will be available. Now imagine from that power available stage, how you are distributing your power lines to the end of the farmlands in all the sites. So where you want to put some power junction points, that is very much important. The junction boxes or a junction points where you want to implement. From there, how the wires will be dragged, that shouldn't be damaged while blowing and while doing some work. So how you are going to distribute through that, and how you will activate these type of actuators and sensors and boards which can communicate with themselves. So this is another one very important thing which in IoT projects you have to think. And then the next one is at low frequencies. sorry, 10 to hundreds of hertz, just only low frequency will be there. It is possible to communicate over kilometers with low bit rates, hundreds of bits per second. Typically, this type of communication was used for a remote metering and was seen as potentially useful for the smart grid. Now imagine a smart grid you are going to do entire power grid, whatever is there, that power grid. I think you have seen many power grid plants. If it doesn't seen means in some Bescom stations and all, they will put a board like that power grids. So if you want to make it as a smart power grids, means how much utilization of power is going on we are taking from a main line and how much it has been distributed to the houses. And there, in each area wise, in that area, how many houses, and another area, how many houses, like that. Now here 10 to 100 hundreds of hertz communication is there and you can communicate that easily over the kilometers. So for that, for communication, how you are using a low frequencies. So that is another one thing which will be there. Using a low frequency is very good. Maintaining that in a low frequency, it's another one a constraint or a challenge it will be there. Coming to the next one, that is LAN and wireless LAN continues to be an important technology for M2M and IoT applications. This is due to the high bandwidth, reliability, and legacy of the technology. So either you are going to use wireless LAN or a LAN, that's a capillary network. You can use this. How you can use this for a high bandwidth? For that you can use reliability will be there. Means you can connect easily to your network and all. And legacy of technologies means hand stage means the cost wise, technical wise, legacy means getting an items for your project or a technology components for your project will be very easy. So that because of that, this type of a capillary networks will be taken into the consideration. Where power is not a limiting factor and high bandwidth is required, devices may connect seamlessly to the internet via Ethernet. So either via Ethernet 802.3 you may connect to your internet, and then either you can go with a Wi-Fi hotspot also. So definitely with a low power things you can connect and you can utilize, you can run your project. Coming to the next thing, that is a Wi-Fi. The IEEE 802.11, that is Wi-Fi standards, continue to evolve in various directions to improve certain operational characteristics depends on a usage of a scenario. So when I should use a Wi-Fi, what stage I should use a Wi-Fi, how a Wi-Fi connectivity I should establish. For example, communicating from node to node or device to device. In entire 3 acres, the one where I kept assume that 50 nodes is being used. For all 50 nodes connecting to the hotspot, it will be a problem. So that you have to think. This is very much important. So then how you are going to do? That means I will place a devices where one device will communicate with another device when it wants to send in a data. Assume that at the same time, if this node wants to send in a data, how to distinguish between the data? Why? Because both the nodes are looking, having a sensors of moisture level sensors will be there, and same type of data is coming. So which sensor is giving which data? So that is very much important here. So how you are going to bifurcate that? Then how you will make communicate this particular means with node to node communication, how you are going to do. And after doing a node to node communication, finally you will come to one particular node which is nearer to the farmhouse where a hotspot is there and you are going to connect to an internet. So for this and all, the Wi-Fi challenge, that's how to distinguish and all. A widely adopted recent release of 802.11n, which was specifically designed to enhance the throughput of that. Means if more throughput is there, especially it will be using for a multimedia streaming and all. So that version of Wi-Fi is good. Next. Bluetooth. When to use a Bluetooth technology? So this is another one thing. Either I can communicate with Bluetooth to Bluetooth. It's left to you. Depends on your project. So why? Because low energy will be there in a Bluetooth. That you have to know. In a recent 2010 integration of Nokia's WebRay standard with the main Bluetooth standard, means now Bluetooth is okay. So what having a more energy also, but limited with the Wi-Fi, not like a Wi-Fi range, but still some 10 to 20 meters you can connect. So it depends on your project that either with the Bluetooth I can communicate with my other node of an Arduino or Node MC or a Raspberry Pi, or how I will do a network distribution. It's left to you and or left to the application of a project, how you are going to implement it. So any doubts are there in between, you can interrupt me. If you may get a doubt in regarding your project also, you can interrupt me and you can ask me, right? So it is designed for a short range, that is only 50 meters in a range applications. In 50 meters they will tell, but in practically the Bluetooth almost all 10 to 20 meters according to me in our the Bluetooth adapters, whatever will bring from the local vendors, it will be so it will be around mostly 20 meters. Yeah, that's the thing. In healthcare, fitness, security, in fitness and security, etc., we can use that where high data rates are required to enable the application functionalities. It is deliberately low cost and energy efficient by design and being integrated into the majority of recent smartphones. So it's very easy to connect with the smartphones and all using Bluetooth. And the Bluetooth to Bluetooth connectivity establishment is very easy comparative to the Wi-Fi, even though it's with a low energy. Means you can see that this much energy is efficient for me in my project. So you can use a Bluetooth. It's left to you how you are going to uh, communicate with node to node and all in between. Next, the another one very important topic in this particular chapter is on data management. Now, network thing we have completed. Any problem is there in a network thing, you can ask the questions. Any problem is there in a network, you can ask the question. Any problem? Any doubts? Any doubts? So agricultural project doing students, what I have told examples, you got it, I think. You always see the students, you should think, when I'm teaching this theoretical part, you should think in a practical way. If I will do this type of a project in a fields or in an environment, so what is the situation? Like that you have to think, and you have to do the things. Now coming to the data management. In a data management, first we'll move with an introduction. What we are going to learn in this data management? Data management is a very much important thing. Rather than after connecting your hardware sensors and your sensor is sending data, data is coming, everything. So that management of data is a no. From sensor to your business or your enterprise level, what data it's generating at what level, then how you are managing that data, and in the next stage, how this data will become an input, and from there, what data that layer will generate, and how to manage that data. Either what part of data should be given as an input and what part should be taken out and stored in other cloud like that. So how to manage it? The management of data means don't think like that in a cloud we'll do the data management. No, it's not purely wrong. The data management you are doing from a basic sensors to the cloud and from a cloud to your mobile app. Everywhere the data management will be there. So introduction. Modern enterprises need to be again and dynamically support multiple decision making processes taken at several levels. In order to achieve this, critical information needs to be available at the right point in a timely manner and in the right form. This is, you see the beautifulness of this particular sentence. Modern enterprises need to be again and dynamically support multiple decision making processes taken at several levels. a decision-making process. For that, I need some dynamical agile support of a data. Without support of a data, how I can take a decision? So this is very much an important thing. Assume that without knowledge of that particular or without having enough information or anything, we can't take a decision. So for decision making process, the data plays a very much important role. In order to achieve this, critical information needs to be available at the right point in a timely manner. Means to achieve the decision making process, we need a critical information, very important information we need at the right point of time and in right forum. This is important. At time that particular time I need that information. After that time, that information doesn't have any meaning. 1 minute. Just a minute. Right, it doesn't have any meaning after that particular moment if I get an information. For example, assume a fire extinguisher. Fire extinguisher and a critical information I need. What information I need? Either fire is there or not. Assume a fire has been occurred and you have implemented the fire extinguisher project is there of Surya and Naina. Fire occurred, your project files and your sensor files to detect the fire accident and it files to give the value sensor it files to activate at that time. What's the need of your project? So what actually mean that when fire occurs, assume in other time it may be worked while showing a prototype or while showing a demo and all it worked. Assume you have implemented practically that somewhere in a house and fire accident occurred, it doesn't give the information. Okay, assume seminar that your sensor has given a information and to the board and the board it has been came and there your program doesn't work. So this is another one very much important thing. At that particular event, at that particular time, your information, what is there, that should be given, and automatically the alarm should be intimated in a fire extinguisher stations, and as well as SMS should be sent. So if that is not done in a right time, so how we can take a decision in that particular time to move the fire extinguisher? How fire extinguishers come to know that a fire accident has been occurred? So these type of things will play a very much important role. All this info is the result of data being acquired increasingly by the machine-to-machine interactions, which in junction with the processes involved assist in better decision making. So everything depends on what it depends. The machine to machine, the sensor should communicate to board device and device should communicate with its microcontroller. A program should run, it should take the required threshold value and that value should be kept to the cloud. So everything should go according to the conjunction of a process involved here. And for then you can take a best decision making process. Some of the key characteristics of M2M data include what are the key characteristics of especially machine-to-machine communication, what types of data will be there, and how you need to manage with these types of data especially. So a big data, huge amounts of data are generated, capturing related aspects of the processes where devices are involved. A bulk, huge amount of data will be taken, and in that particular data, you should analyze and manage the things. So that is called as a big data. For example, you can take the air pollution monitoring or entire border. The sensors will be there and IDS system. Video, surveillance camera, IDS systems. These things will fall at this particular stage. For example, surveillance camera IDS, where Gaurish they are doing. In that particular thing, how much video we should record? Who is the intruder here? So how to detect intruder in that video? Assume I will kept a camera. When intruder will come, no one can expect this. So when intruder will come means I can't expect when he will come. He can come anytime in 24 hours. So then what to do? I will put my camera, let it be keep on watching. When some motion will be occurred, each motion I will keep on catching that motion and I will see either he is an intruder or not. That means your camera footage, whatever should be there, that should be taken continuously 24 hours. Imagine 1 week of that video, how much it's cost, how much big data will be there in that. So in that big data, you have to process this, means point to point, you have to process at which time it has been there. Alarm should be given. So it should be recorded. So these things plays a very much important role in projects. Then coming to the heterogeneous data, this is one of the peculiars and a challenge type of data. The data is produced by huge variety of devices and is itself highly heterogeneous, differing on its sampling rate, quality of captured values, etc. What is this heterogeneous data? A video data will be there, voice will be there, and then some other sensors, temperature I am going to consider, and even I will consider some other things. All these are heterogeneous. One way I am going to consider a temperature and all. In another way, movement of sensor I am going to consider. In one way, PIR means motion sensor I am considering. In one way, video streaming I consider. In one way, noise detector I am considering. These are the heterogeneous of a data. Now, in this heterogeneous of a data, what in a samplings of this? So, how should I solve my problem? Means what quality of values I should take into the consideration and what values I should store. So this is another type of data where a different types of data will come to one stage at a time. Next, real world data. This is another one type of data, real world data. The overwhelming majority of the M2M data relates to real world process and is dependent on the environment they interact with. This is damn. What is the real world data? The real world data is nothing but air pollution monitoring, for example, and moisture level monitoring, temperature monitoring, humidity monitoring, and other things which you are monitoring from an environmental fire detections you are doing. So all these things related to an environmental issues. So these environmental real world data, how you are taking and how you are analyzing this type of data is another one constraint or characteristics which will be there. And real-time data, see here, real world data is different and real-time data is different. What is this real-time data? M2M data is generated in real time and overwhelmingly can be communicated also in a very timely manner. That is real-time data. What is real-time data? Real world has given you some data. At that particular real time, you should act something. You should communicate at that timely manner. If fire occurs, then automatically your fire sensor should detect that and the alarm intimation should be given. Then uh, then the latter is of pivotal importance since many times their business value depends on the real-time processing of the info they convey. Many times the latter is of pivotal importance since many times their business value depends on real-time processing. How in that particular time how the processing should be done and how you should activate other actuators or alarms or something sending an SMS something thing and all how you are going to do. So that plays another one important role. Then temporal data, the overwhelming majority of M2M data is of temporal nature. Just a minute. Next, so the temporal data. What is this temporal data? The overwhelming majority of M2M data is of temporal nature, measuring the environment over time. Just for that temporary purpose, I need this type of data. If something happened, I need that data. Otherwise, no need to store. For example, assume fire accidents. If it is a normal temperature, nothing has happened like that, fire is not there. So okay, no need to store that data and I'll keep on living. When a gradual temperature has been increased, for example, I will keep a threshold. If temperature is more than 38 degree, 40 degrees Celsius or 42 degrees Celsius in one particular area, I got it out. So you keep on storing that. So until then, it doesn't store. What is the temporal data? Just in a catch, it will take the present data and it will see, yes, this data is of 30 degrees Celsius, not needed. Remove that data. That is called as a temporal data. Spatial data. Increasingly, the data generated by M2M interactions are not only captured by mobile devices, but also coupled into the interactions in specific locations, and their assessment may dynamically vary depending on the location. So location wise, the data may differ. Means capturing of any data by mobile devices, maybe I can say like that, and any sensors also depending on areas, locations. So how it is making giving a things assessment may dynamically vary depending on different locations. So that based on locations, you have to rectify the data. For example, I can say like this in mountains regions, how you are collecting your data, in a forest regions, how collecting your data. The locations is entirely different. The geographical things will be different there. So there, how your sensors will work and how you are going to collect the data, that plays a very important role. Coming to next, polymorphic data. Now, polymorphic data, the data acquired and used by M2M processes may be complex and involve various data, which can also obtain different meanings depending on the semantics applied and the process they participated in it. What is this polymorphic data and mixed data? For that, you are going to apply some other side. I will take some information or a data and I will put on that. Then I will extract what data I want from that. So that is called that bulk data. For example, assume for MQ135 sensor is there. MQ135 sensor, it will detect a gas. So I want a particularly methane. So I want particularly to detect a methane gas at that particular time, not a LPG, not a alcohol like that. How methane will be taken? For example, based on a value, reading value. For a methane, the value of an sensor, if it is from this range to this range, then there the methane gas has been value, means it's there. Or alcohol, the range of values will be so and so. So what I will do, I will bifurcate that value. I know that value chart in my this one means I'm having, so this range to this range alcohol, this range to this range carbon monoxide, this range to this range carbon dioxide, and this range to this range methane will be there, and LPG will be there, CNG will be there, like that. So based on the value, whatever it came, then I will process here again will process with that chart information. I will see which gas it is. So that type of a thing is called as a polymorphic data. Then proprietary data. What do you mean by this proprietary data? Up to now, due to monolithic application development, a significant amount of M2M data is stored and captured in proprietary formats. However, increasingly due to the interactions with heterogeneous devices and stakeholders, open approaches for data storage and exchange are used. Some proprietary data will be there. This data is mine. You can't use this particular data. For example, assume Havamanavardhi means the nature weather report I want for my project to calculate something. So how a weather report of daily weather report from a satellite report I will get. So that's a proprietary data. So I need some permissions and all where I can get that particular data and I can use it where different stakeholders will be there and they can use that based on some paying or some having a request with them if it's a government website and so these things can be taken and based on that you can implement your project. Then, security and privacy data aspects. Due to the detailed capturing of interactions by M2M, analysis of the obtained data has a high risk of leaking a private information and usage patterns as well as compromising security. This is a major. Here, any personal issues is there. Surveillance of a camera. Where to place camera? This is important. What events there actually will occur always, what events, some privacy events will occur there. I can't keep a camera there. So you have to think, so which is the privacy and which is the thing, something like that. For example, I will tell you, you have placed a camera in for intruder detection system, assume that something has happened, somebody has killed some person or something like that has happened. So directly you can't publish the data in a television without giving a police complaint. You have to give to police. That particular manner, which information should be given to whom, and what usage patterns you have to use to analyze that. That is an important thing. So that type of data and all should be maintained, privatized, and that data should be shown to others. What about the security for that? So that things will be taken care in this particular data aspects. In the era of M2M, where billions of devices interact and generate data at exponential growth rates like this, there's a chart. Assume per day how much master level sensor value I will get if I keep sensor into the field. One sensor, just a one sensor, 24 hours, assume. So you will tell, sir, maybe some 20 to 30 values I will get, or even 100 values I will get per day from one sensor. 3 acres of land, assume some 100 sensors, 200 sensors. So how much value you are going to get, how a value will increase in a graph. So for precision agriculture, what we have seen in our activity, for precision agriculture system, these things plays a very important role. The data management is of a critical importance as it sets the basis upon which any other processes can rely and operate. With your data management only, you are going to decide what to do. Means either actuator should run or not, either motor should on or not, either alarm should on or not, either notification should be given to the mobile or not. Everything will depends on your data management, how you process the data, either that data has gone there or not. So everything will depends on data management. That's why data management is a very important aspect in a IoT project. Now, managing M2M data. How you are going to manage this M2M data? You can see here information stream, that is a business evaluation process, whatever is there. Now, from below we'll move, sensors is there, sensor networks, information stream generating sensing. By sensing whatever information is getting that has been generated here. Data processing network point means whatever information is came, data has been processed here. Right. Now, in transit information stream adaptation, computations. That is here data processing you are doing in different levels. At a first level, what you are doing, gathering, bifurcating, filtering, something like that. And later on, you will do with some other things. And later on, you are going with cloud data where you are storing and taking out and making some business decisions with filtered and aggregation of a data. After doing that, after clustering the data to a particular information where a knowledge frames can be created, and through that knowledge frames the information stream business evaluation can be done taking decisions. So this is the entire of a chart how the M2M data management will be done. The data flow from the moment it is sensed example by a wireless sensor node. Up to the moment it reaches the backend system has been processed manifold, either to adjust the representation in order to be easily integrated by the diverse applications or to compute on it in order to extract and associate it with a respective business intelligence. So from this point to this particular information from business point, the data flow, the movement, whatever is there, so that M2M data that we are going to consider that should be managed. Managing M2M data, we see a number of data processing network points will be there between the machine and enterprise, where sensors to the enterprise that act on the data stream based on their end application needs and existing context. For example, what is the first the end data processing network point will do? Whatever a sensor data is there, it will take and it will consider which data it wants. This type of data, aggregating data in one side, grouping a data, filtering a data, everything will be done. After doing that, the data will be whatever required data is there, that will be sent to the cloud. In a cloud, while moving into the cloud itself, different databases will be there. For master level, one database, this one, like that. Means temperature, one will be there. Quantitatives, one will be there. So the data should move to a particular there. So there, the data processing network points, what it will do, to in which database this in a cloud it should be put according to the entity or a fields. So it will place there. After placing there, they again in a cloud now data everything is ready. Now based on what type of data is kept and based on a threshold value, some logic and all, now we should take a decision either to run an accurator or to give a notification to the mobile, something like that. So this is your end process, means other end process informations which you are going to give. Dealing with the M2M data may be decomposed into several stages, which we briefly outline below. Now, below you can see the next stage, how a data will be moved in different stages, means decomposed in different several stages, which you can see. The first in that is a data generation. So first a data should be generated to manage a data. How a data generation you can do? Data generation is the first stage with which data is generated actively or passively from the device system or as a result of its interactions. The sampling of data generation depends on the device and its capabilities as well as potentially the application needs. Now observe carefully, the data generation is the first stage within which the data is generated actively or passively from the device. Actively means at that particular time sensors will sense and it will sense. Passively means whenever a particular event will occur, it will sense, it will become activate, it will sense and it will take a data. So in both the ways, from that device, the data will be collected as a result of its interactions. The sampling of data generation depends on the device and what type of the capabilities as well as potential your application needs. What data I need and what are the equipments you have installed or technologies, whatever you installed based on that sensors. Based on that, the data will be generated. So this is another one important concept. We'll stop here and we'll go for attendance now and I will continue in after classes. Just a minute and take attendance now. Let's stop sharing. Now answer your attendance. Aditya?
Sir.
Ajay,
Yes, sir.
Amit,
Yes, sir.
Antima,
Present, sir.
Apurva,
ಸರ್ ಅವಳದು ನೆಟ್ ಪ್ರಾಬ್ಲಮ್ ಅಂತ ಬಿಟ್ಲು ಸ್ವಲ್ಪ ಹೊತ್ತು ಮುಂಚೆ ಅವಳು ಇದ್ಲು ಇಷ್ಟೊತ್ತು.
Ashwini, Ashwini, ಇಲ್ವಾ ಅಶ್ವಿನಿ? ಬಿಂದು, ಬಿಂದು ಇಲ್ಲ, ಬಿಂದು ಬಿಂದುನು ಇಲ್ವಾ?
ಇಲ್ಲ ಸರ್.
ಓಕೆ. ದಿವ್ಯೇಶ್, ಏನಾಗಿದೆ ದಿವ್ಯೇಶ್ಗೆ? ವಾಟ್ ಹ್ಯಾಪನ್ ಟು ದಿವ್ಯೇಶ್? ಗೌರೀಶ್,
ಎಸ್ ಸರ್.
ಗೌತಮಿ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಗುಣಶೇಖರ್,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಹರಿಣಿ,
Present, sir. Present, sir.
ಆಯ್ತಮ್ಮ. ಸೂರ್ಯ, ನಯನಾ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ನಜ್ಮಾ, ನಜ್ಮಾ, ನಿಧಿ, ನಿಧಿ, ಪ್ರದೀಪ್, ಪ್ರದೀಪ್ ಇಲ್ವಾ ಅವನು? ಇಲ್ಲ. ಪ್ರೀತಿ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ರಾಜೇಶ್, ಸಹದೇವ್, ಸಹದೇವ್ is not there. Sahadev, no. Saket,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Santosh,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Seema, Sinchana,
Present, sir.
Spurti,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Shashank,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Varsha,
Present, sir.
Yashashwini, Yashashwini, Amrita,
Present, sir.
Amrita,
Sir.
Anusha,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Apurva K,
Present, sir.
Sai Siddharth,
Yes, sir.
Chetana,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Kavya,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Madhushri,
Present, sir.
Manish,
Present, sir.
Sarfaraj,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Murugesha,
Present, sir.
Mani,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Paresh,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Pooja,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Prashant,
Present, sir.
Pratibha,
Present, sir.
Pratik, ಇಲ್ಲ. ಸಾಧನಾ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಶಶಾಂಕ್,
Present, sir.
ಶ್ರದ್ಧಾ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಶ್ರೀಧರ್, ಶ್ರೀಧರ್ ಇಲ್ಲ. ತನೋಜ್,
Present, sir.
ತೇಜಸ್ವಿನಿ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಅನಿ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಆಯ್ತು ತೇಜಸ್ವಿನಿ, ಹನಿ ರೈಟ್. ಆಶೀಶ್,
Present, sir.
ವಿದ್ಯಾ,
Present, sir.
ವಿಶಾಲ್.
Present, sir.
Yeah, now take a break of 10 minutes. I'll back again with the activity class, or we'll decide what we will do. Exactly 12 o'clock, I will back again.
ಸರ್ ನಿಧಿ ಇದು ಪ್ರೆಸೆಂಟ್ ಇದ್ದಾಳೆ, ಅವಳದು ಮೈಕ್ ಆನ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ ಮೆಸೇಜ್ ಮಾಡಿದ್ದಾಳೆ.
ಆಮೇಲೆ ಸೆಕೆಂಡ್ ಅವರ್ ಅಟೆಂಡೆನ್ಸ್ ಅಲ್ಲಿ ನೋಡೋಣ ರೈಟ್ ಸೊ ಎಕ್ಸಾಕ್ಟ್ಲಿ 12 o'clock I'll join again. Everyone should join. Okay.
Sir, roll number 34 present, sir.
ಆಯ್ತು
Sir, roll number 17 also, sir.
ಸೆಕೆಂಡ್ ಅವರ್ ಇದೆಯಲ್ವಾ ಅವಾಗ ನೋಡೋಣ.
Okay, sir.